Right, we're ready to go. Today's topic is first blood typing and blood coagulation. So blood typing, my attention grabber, is this is the written portion of the next exam. And so let's first talk about why you need to type somebody's blood. This is also Friday's lab. Let's read what I have on the slide. It'll become quite apparent why blood typing is important. When blood transfusions were first attempted from one person to another, immediate or delayed agglutination and hemolysis of RBCs occurred, leading to death. It was soon discovered that bloods of different people have different antigenic properties, so that antibodies in the plasma of the recipient of the donated blood will react with antigens of RBC surfaces of the donated blood. So these details are important. Leading to death is important, obviously. When they tried it, people died, and we can't give, blood isn't all the same. And so what we know of blood now, what I told you yesterday, is when you donate blood, usually it's the oxygen carrying component that you're donating. The packed red blood cells, resuspended saline, reinfused into a person who needs the blood. Hopefully, it doesn't lead to death. So we need to teach students how to safely donate from one person to another. Because we have an immune system. Our immune system is programmed to attack any cell or pathogen that's non-self. Okay, that's what happens when you get sick, right? The virus, the bacteria, they have antigens that present to your immune system attacks it. In this case, we're going to bypass that. You want the donated blood to work in the recipient without the recipient's antibody attacking it. So, here are the different antigens on blood cells. There's actually three. I'll map it all out. There's A, there's B, there's the Rh antigen. O means you don't have A or B. O is not an antigen. I think of O as a zero. You don't have 0A or 0B. It doesn't refer to the Rh though. But anyways, you don't have to know these numbers. But by ethnically, there are these different types, okay, that we teach the students. And what you should think of with regards to yesterday is when you fractionate blood, this is what you donate. But if you're receiving blood, you got to think about what are the immunoglobulins, what are the antibodies circulating in my bloodstream, and the blood I'm receiving, will it attack the blood that's being infused into my body? Okay. The best thing to do if you're planning to have surgery is to just store your own blood. You don't have to worry about it. Of course, you're safe from your own blood. And so the thing I try to emphasize, what do donors really donate? That might be a problem in the recipient, okay, Well, donors are donating their RBCs, and they have these antigens that may be seen as non-self, okay, by the antibodies that are in the plasma component. So, blood typing prevents these transfusion reactions. The donor's blood attacked by a recipient's immune system, the antibodies, also called agglutinins, causes agglutinations. And here's basically what can cause death. Basically, renal failure. If you attack red blood cells, we know that they're filled with hemoglobin. If they burst, and those hemoglobin are circulating free, they kind of clog up the capillaries in the kidney, and that's one of the common causes of death in antibodies. So let's kind of get a picture of this. Whenever you kind of solve blood typing problems in a classroom setting, you always think about the two people that are involved. The donor, so we stick figures, personalize it, and the recipient. One person's donating, one person's receiving. They both have blood. And what we're trying to emphasize is, whatever blood you're donating, for the donor, you're donating the red blood cells. And pretend they have these little shapes on them, like they draw these little triangles. red blood cells with these antigens, I'm not even telling you what it is. I'm just drawing them as triangles. You're taking this blood, and you're going to transfuse it to this person. However, this person may have an antibody in their blood plasma that may actually recognize that antigen and attack it. Okay, we don't even know the type of that person or this person. I'm just focusing on the antigens on the RBCs. For the donors, in this case, the triangles, right? And I'm focusing on the antibodies in the recipients. Okay, this is in the plasma component of the blood. And basically, I drew it like that. I drew the antibody with a kind of a triangle shape, so that if you give this person this blood, with the triangles, which symbolizes antigen, it'll be attacked and actually cause a transfusion reaction. Because you're donating so much of this blood, it's going to cause a big problem in the recipient that could lead to death. Okay, so this will be an example of not safe reaction, because how you state it in words, I hope you understand this. The recipient has an antibody that attacks an antigen on the donated blood. That is the simplest way I can explain what's going on here. Okay, there's a picture there, there's a picture there, and any questions on this? If you can understand this, you understand the key to everything about how to do this. Okay, so the recipient, do they have red blood cells in their blood? That's an easy question. Yes. But do we care about that when they receive blood? No, it's their blood. Why do we care about their blood when their problem is they need to receive someone else's blood? That's their problem. We don't know the reasons why. It doesn't matter. Okay. Maybe they're chemotherapy. They need to be transfused. Yeah, there's a lot of different reasons why you need to get blood. We don't care about the red blood cells. We care about their immune system and if it's going to attack the donated blood. Okay, when you donate blood, do they have immunoglobulins? Do they have antibodies? Let's assume you're not donating that. You donate the packed red blood cells. Write that down again. And remember, because I'm always helping students later on in days to come. And you always tell me about their antibodies, and you say, oh, it's going to react in this. No, just write this down now so you don't get confused later. You're not donating their antibodies. You're donating the oxygen carrying component of the blood. And that'll really save you a lot of misery. I think I've seen all the ways students struggle with this, but there's always at least one new way I see in every class. And so I'm just curious, what's it going to be this time? But as I do it, I get better and better at teaching it. Maybe we can have 100% avoidance of confusion. Okay. Well, anyways, like I just got through emphasizing, number one, consider, to prevent this from happening. The donor, antigens, antibodies, okay, what's on their RBCs? Let's get that straight. The recipient, what do we care about? What could cross-react? Well, they have an immune system. Yeah, you have to know the antibodies that could possibly cause a problem. So, if you can kind of make sure that the recipient doesn't have antibodies that attack donated blood, that's okay. That should be safe. Okay, yeah.
Are you saying that the plasma in the recipient has globulins that are the antibodies, and
yes,
that is what's going to attack the red blood cells from the donor?
Mm-hmm.
I just want to make sure.
The antibodies in the plasma.
In their plasma.
Yes.
The recipient's
in their plasma.
Okay.
Yes. That is the key. That is the key. Now, for any blood type, just, blood type A, what does that mean? And this kind of exemplifies one of the antigen systems that are used that we've discovered is a problem for blood transfusions. There's actually two systems. So let me just kind of like do all the systems and just, I don't even want to look at this. I'll tell you what's important here. There's one system called the ABO system. There's what's called the A antigen. Let's say you have type A blood. Type A means the A antigen is present. When you say a person has type A blood, that's kind of what we mean. Okay. There's type B. And the person that has type B blood means the B antigen is present on the RBCs. Type O, as I said previously, that means A and B are both absent. However, that's two antigens, right? The A and the B. There's a third antigen. It's called type D or RH. RH antigen system. Now there's different subclasses of this RH antigen, which stands for rhesus monkey. That's one of the first mammals they kind of discovered it on. And we have it too. And well, sometimes they refer to RH antigen as type D antigen. I usually go with RH. But should you see type D show up on anything we do, you know it's that antigen. Well, anyways, they denote this type differently. They use pluses and minuses, and they use it as a superscript with the ABs. So, for example, if you see a plus as part of a blood type, that means the RH antigen is present in that blood type. Plus means RH antigen is present. Antigen is a word that means antibody generator, because if a person is exposed to it, that person's immune system generates antibodies to attack it. These are what antigens are. All right. Well, so then, what do you think negative means? It's not there. RH antigen is absent. So you combine these two systems, the ABO, the plus minus. I mean, really, it's the presence or absence of three antigens, the A, the B, the RH. That's what I have to keep straight in your head. So let's go through all the blood types. Every single one of them. And let's keep track of what antigens are on the RBCs, and then what antibodies will be in the plasma for any given blood type. For example, let's start with A negative. Type A negative blood, if I draw a circle that represents a RBC, there's one antigen present. Which one is it? A. And why don't we get, how about I use triangles to represent A antigen? And how about I make an antibody with the same shape as a triangle to represent the antibody against A? Anti-A or A antibody. How about I use circles for B antigen? And I'll use a circle-shaped antibody for B. For those of you who already took micro, you might raise your hand if you took micro. So I'm speaking to some people who kind of have been exposed to antibodies. For those of you that haven't, don't worry about it. You see what I'm doing here. A circle is a specific shape for that antigen. It's a specific reaction. The circle-shaped antibody, can it react with a triangular-shaped antigen?
No.
No. Okay, that's all I'm trying to say with the shapes. Their specificity. So this end is specific. The tail end is a non-specific fragment of the, yeah, that's all you really need to know. Well, the third antibody was RH. And how about I use how about I use square to symbolize RH antigen? And so I'll draw a square-shaped antibody that is specific for that. The antibody against RH. Okay, so that's my system that I'm going with. I go with the same shapes every year. Okay. Well, if you have A antigen present, that means I'm just going to draw triangles in this person's RBCs. Now, what you can assume is that in your patient or whoever you're working with in the clinic or in the hospital, you should assume that if they're type A, that they have the antibodies against the other two antigens. Assume they've been sensitized to them and have developed them and have them. Okay, just assume it. Otherwise, you're taking a chance. So if they have the antibody, if they have antigen A, assume they have the antibody against B and RH. So assume they have anti-B, anti-RH in their plasma. Just assume that. Okay, well anyways, any questions on what I just did for one blood type? Keeping track of the antigens in their RBCs, and we keep track of the antibodies in their plasma because you don't know if I'm going to ask you if that's a donor or a recipient. So we keep track of both. A positive, how many antigens are present? Two. Well, the A and the RH. Okay. So let's go with the triangles and the squares. Now, which antigen is absent? It's the B. So assume they have antibody against B. So that's A positive. Let's go B negative. B negative, which means they have, I'm just going to draw little circles there. The B antigen is present, and assume they have the antibody against A and RH. Okay, and keep going, B positive. They have circles and triangles, squares, circles and squares. Keep my shape straight. They have the B and RH antigens, they are present, and the antibody against A, they have that. All right? Let's see what else is there. Oh, okay. Well, you have this type, AB negative, very rare, but they're out there. Type AB negative. And the antigens present are A and B. No RH. But they have the antibody against RH. And then there's a very rare type with all three present. Type A, B, positive. Okay. I want to go back and look at that table just to see what the prevalence was. Yeah, off the top of my head. Yeah. Only 4% are AB, and okay, yeah, it's a very low percentage. Anyways. Go back to where I was, sorry. running out of room on the board, but I should have space to draw my RBC with the A, triangles, the B's, antigens, the circles, and the RH squares. So they got all three. Which antibodies do they have? You can assume they have none of them. They have no antibodies against A, B, or RH, or you attack yourself, and that's not going to happen. So I'll say no ABs, that's my shorthand for antibodies, against A, B, or RH. So this is a special blood type that we call the universal recipient. Because you can receive blood from any type, because you don't have any antibodies that would attack the donated blood, at least the ones we care about, the A, the B, the RH. Okay? Of course you have antibodies. Sometimes students write about this on tests, and they always make the mistake of saying, this person has no antibodies, period. Now why is that wrong? They have antibodies, just not against these three. So don't make that mistake. Specify which antibodies they don't have. And they can receive blood from all these types. Well, I didn't list all the types yet. We have type O. O neg. So I'm going to draw a red blood cell. A is absent, B is absent. What about RH? Absent. No antigens. Assume they have all the antibodies. Antibody against the A, the B, the RH. Now they call this type the universal donor. And maybe you've heard that. You watch TV shows. I need O-neg stat. Universal donor. I mean, I'm not a clinician, but I've had students, they tell me, oh yeah, I work in a hospital, I was studying this, and the nurses come along, yeah, that's true. I mean, this stuff does work in clinical setting. So, why do we call it universal donor? They can donate to which blood type? Any of them. Why? What makes them a good donor? Yeah, there's no antigens, there's no A, there's no B, there's no RH. There's not going to be a cross reaction. Because it doesn't matter what they have. They don't have an antigen that will cross react. Okay? They have O positive. They have, well, they don't have A or B, but they do have RH. Squares. Assume they have antibody against A and B. Okay, well that's all the blood types. That's all. And combines the ABO system. And it's all about presence or absence of antigen.
So type AB, if they're universal recipient, but they have all of that, they cannot donate, right?
They could.
They
to,
could?
to another AB positive.
And that's it though, right?
Yeah.
Okay.
Pretty much. Yeah.
How about types O plus? Can donate the O plus type for the blood?
Yeah. Well, let's go through the thought process of where you guys are going. Kind of like leading me to my next point. Can this person donate to that person? Is basically where we're going with this. So let me take you through the thought process of how everyone should do it. Okay? All of you do it this way to start, and sometimes students come up with shortcuts and you tell me about it, and it's like white noise. Okay, that's good for you. I just know this, and this always works 100% of the time. Okay, whichever way you come up with it, it works great. This way works, everyone should understand it. Here's the thought process you go through. Yeah, clear the board here. So what I did was I made a bunch of questions in a way where this is how I want you to think about solving these problems, and these are the kind of things I ask you on exams, quizzes, and I should give you a little prelude for Friday's. Friday, you have a quiz in the morning, and you have a lab. That lab, you also have an oral quiz for the blood typing lab. I always do that, so I'm going to give you advance notice on that. I'm going to have your group come up here, you stand there, and I'm going to have each of you answer one question right in front of me, oral quiz. And I want to see that you can explain this to me verbally as part of the quiz. Because it's easy to go through that lab and do it and get nothing out of it. At the very least, I'll have your group walk up and explain some of these things to me orally, so just kind of anticipate that for lab on Friday. Okay, here's my question to get you started here. Can John donate to Peter? John is AB positive. Can he donate to Peter? He is A positive. And so whenever you do this, always say, who's the donor, who's the recipient? And so the first thing, before you even try to answer it, just what do you consider? What do you consider for John? Antigens or antibodies? Antigens. John's antigens.
It says John's AB negative.
Oh, I'm sorry. Thank you. And you consider Peter's antibodies. Consider antigens. So which choice is that? John antigens, Peter's antibodies. Yes, choice B on the multiple choice there. And so if I draw a little red blood cell, I'm going to draw the AB negative blood will have the A's present and the B's present. Okay. Well, what I do for recipients is I draw their antigen just so I don't confuse myself, and then I draw the antibodies. So he's going to have on his blood the A's and the RH, which leaves he will have the antibody against B. He will have that, anti-B. And that's what we're concerned with him. Okay, so, okay, we got that there. And I think I answered some of my next questions here. For John's blood type, he will have, and we got it there, he has two present, the A and the B. And that's choice B on this list of choices. For Peter's blood type, we established he has only antibody against B. Right there. Okay, this is kind of the thought process you go to. Then you try to figure it out. Okay, so you give this guy his blood, and just at the very surface level, just grab a random person off the street. They can tell you, oh, an AB can't donate to an A. They're different types. They don't got the B. Then you'll be correct. But here's the specific reason why you can't do it, because the antigen B will be attacked by an antibody against B. So there's a cross reaction. You always want to write that out. Okay? Don't just say the blood cross reacts. You have to identify what cross reacts, because there's three possibilities. And in this case, what we see is Peter's B antibody attacks John's B antigen. So let's see if that's one of the choices. The answer is going to be one of the no's. You cannot donate safely. Okay? And there it is right there. John's B antigen will react with Peter's B antibody, stated slightly differently. Okay, so basically, any questions on that process, what we just did with John and Peter?
When we do our oral quiz, you're gonna let us use the whiteboard and just let us.
You could.
Visual.
You could. I have some other typical questions you could practice in the study groups later. What I want to do is kind of go over more general rules with you using this table. So how you read this table is donors across the top, recipients on the side here, and the check mark means okay to donate. Okay. So let's kind of go through some general rules. So what are some generalities? Let's start with this. Think about the RH thing. Can negatives donate to positives? Let's start with that as a general rule. Let's just look at the table first and talk about why or why not. Okay, I'm saying can negatives donate to positives? Okay, here's my negatives. And it looks like they can donate to positives. I mean, yeah, here's a negative donating to this positive, so it can happen. Yeah. And it looks like negatives can also donate to negatives. Okay, so what's the reason behind it? Just in terms of RH, I'll draw a red blood cell. Do they have the antigen? They don't have the antigen. So let's say they're the donor, recipient, and let's concern ourselves with only antibody against RH. Can this red blood cell with no RH antigen be given to this person who has the antibody against it? Yeah, it doesn't matter. They don't have it. It's not going to cross-react. So it looks like this person who is negative can donate to someone who is positive. So that answer is yes. In fact, we can take it a step further. Not only can negatives donate to positive, negatives can donate to negatives, right? Okay, well, then reverse the question. Can positives donate to negatives? Let's first answer the question by just looking at the table. Can negatives donate to positives? Here's my negatives. Let's see, here's my positives, they're the donors. Here's my negatives, here's the recipients. Why are all these blank? Can't do it. Not okay. Positives cannot donate to negatives ever. And this is the same reason. I'm not presenting new information. Okay, this is the donor. Okay, if you're RH positive, you have the anti-gen RH. If you're RH negative, you don't have it, and you do have the antibody against it. So this is a no, because you would have a cross reaction. So positives cannot donate to other people who are negative. Okay, so that's one general thing. But it's the same logic. The antigen's there or not, the antibody's there or not, and prevent a cross reaction. What are the other generalities? One thing I noticed is like this one, look the diagonal. It's okay all the way diagonally. Now what's going on there? O positive, A positive, A positive. What's the other general rule? If you have the same blood type, you can donate to the other same blood type. That's another general rule. That goes without saying. I said it anyways. Take the same type. Other general rules. Let's see. Oh, okay. Well, that we talked about already. Why is this? Why are they all checked here? Who's this guy? Universal donor, right? Oh, look, AB positive. Why is it checked all the way across? Universal recipient, received from anybody. And I think those are basically the general rules I like to talk about with this table. Stare at it some more if you like, but that's the basic idea. Now, the lab is different. You're going to type blood first, okay? And so how do you do that? Well, you have to have a test and a method, and you don't know what the blood is. Unknown blood. Person comes in and you got to figure out what blood type they are because they need blood. You got to give them blood, and you don't know what the blood bank has, and so type them to figure it out. So we have 3 wells in each of our 4 cases, and this is a good example because in your lab you're going to have 4 unknowns, different from this, but 4. And in your lab you'll have antibody against A, B, and RA. So you have the antibodies in your laboratory. Anti-A serum, anti-B serum, anti-RH serum. It's the antibody against those antigens. And what you do is you take your unknown blood, you don't know, okay, let me say it this way. When you type unknown blood, you're testing for the presence or absence of antigens. Let me write that down. And which antigens? A, B, RH. The triangles, the circles, the squares that I've been using as symbols. That's what you do. Is it there or is it not? Then you can identify the blood type. So let's do number 1 together. So I got my 3 wells. Looks like the first well, no coagulation. Okay, I got my blood there. I added anti-A serum. That's antibody against A. And I throw it onto this blood, and nothing happens. Negative result. No agglutination. You add the antibody to the well, nothing happens. What's the interpretation? This person does not have A antigen. They're not type A. So what you would say was, I asked this question, like you say no agglutination. Sometimes you report it as negative, and I ask you to answer the question. Oh, so you said this is negative. What does that mean? And here's what you say. This is kind of funny. Oh, it's negative. Interpret. What does that mean? It means it was negative. What does that mean? Why did you? You just keep telling me. You just have this go around in circles. It's negative. What is that negative? You just keep. It means it's negative. You're not interpreting the result. What does this mean? What are you doing? Testing for the presence or absence of what? A. The correct answer is, oh, it's negative. That means A antigen is absent. That's all you got to say. Sometimes it takes us 5 minutes to get there. And like once you figure that out, you're like, is that it? That's all I had to say? Like, yeah, that's what this test is. All right, so then you add antibody against B to your well. Oh man, it clumps up. Clumpy, clumpy, clumpy. Clumpy, 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 clumpy. It's positive, agglutination. What's the, how do you interpret that result? B antigen is there, it's present, because it reacted with the antibody you added to the well. That's how you can make that conclusion. So you know they're type B, then you have to do the RH. Added, nothing happens. Negative, no agglutination. So what's the blood type? B negative. Okay, so that's how you do it. So then what's number 2? O positive. What's number 3? B positive. What's number 4? O negative. And once you practice, you'll get good. It's pretty easy once you understand the principle. Right? Okay. One clinical example for to avoid in pregnancy, hemolytic disease of newborns, aka erythroblastosis fetalis. Okay, so here's the example. Let's say that you have a baby, mom and dad, and mom's Rh negative, which means no Rh antigen present. But maybe due to genetics from dad, hey, fetus is Rh positive. When baby's born, as you well know, there could be exchange of blood between baby and mom. So maybe mom's blood picks up some of the Rh antigen. Okay. And baby's going to be okay because they're out of there. This happens during birth. So they're gone. Right? But moving forward, mom's Rh negative blood is exposed to this antigen. So she starts to produce antibodies. She gets her antibody titer against Rh up. So second baby comes along, there could be a problem. Because now Rh antibody titer is up in mom. You can cross the placenta and attack second baby who is still Rh positive. Okay? And so you can kind of prevent this by just, they have Rogaine, just give it to them. Just to sop up all the antibody that might be there. But that's one clinical example, and what you should understand now that you know how cross reactions take place. So my last slide will just remind you what I already talked about with the physio lab, so I don't need to hammer that again. So to shift gears from blood typing to blood coagulation, that's my next batch of slides. We shall come back to blood typing in the lab. And shift gears, I'm going to talk about first formation of white blood cells. In the bone marrow. I talked about bone marrow before. On this slide I have just numbers. You don't have to memorize the numbers, but I just want you to appreciate daily output. Billions of cells are put out by the bone marrow every day. The lifespan of an RBC, a few months. White blood cells, much shorter. Okay, because of the thyroid infections for us. Billions of cells. Here's a picture of bone marrow. And you see the cells, the little purple and pink cells. We call that marrow cellularity. Now the white is adipose. And as we age, the white adipose takes over. Okay, and you lose your bone marrow. But in an adult, it should be about 30 to 40% marrow cellularity. The details I want you to know, we talked about how red blood cells form from hemocytoblasts. Now I want to talk about how the white blood cells form. Let me draw a generic cell at the top of the board, and we'll call it a hemocytoblast. Generic cell. Hemocytoblast. What I had said prior was for red blood cells, put a big arm over on this side, we had talked about how EPO is important for development past the urethroblast stage. I don't know if you remember that from yesterday. And once you also have iron and B12, you can progress to normal blast stage. Kick out the nucleus, reticulocyte. And then you have your good old erythrocyte, or RBC, that gets into the circulation. So this is kind of the same thing, but for the white blood cells. If you stimulate cells with something that's called, I have it on the slide there, it says GM-CSF. I should write that out for you. That stands for granulocyte, monocyte, colony stimulating factors. I'll write it out for you. How about over here? Granulocyte, monocyte, colony stimulating factor. That factor will form these little colonies of cells. I draw a little cluster of cells. They're still stem cells, but they've progressed past the hemocytoblast, and they're getting to this committed cell pathway there. Okay, I'm not going to make it learn all these names. Let's just say that out of these little colony-forming units from the GM-CSF, you're going to get granulocytes and monocytes. Those are the two general categories. What's right here on the bottom? Granular cells, agranular cells. Let's kind of go there. Granules are filled with defensive molecules. Some white blood cells have them, some don't. That's how histologists have categorized the white blood cell. Some of the granular ones there's another factor that gets you to this more specific category, GCSF. Not GM-CSF, GCSF, just drop the M, same thing. And that they will give you your granular ones that we've talked about already. Right here. That says eosinophil, basophil, neutrophil. Let me write them down. Eosinophil. Basophil. Neutrophil. Okay, those are the granular ones. The agranular one I want you to know is monocyte. We can ignore lymphocytes for now because I have a whole lecture on that later. Probably get to it Thursday or Friday. Now, to get to the agranular side, you need MCSF, monocyte colony stimulating factor, to get you out of these colony forming unit here. And anyways, the ones that have little dashes next to, these are the mature cell types that enter the bloodstream to fight infection. That's your Buffy code, right? Now, the only cell I haven't talked about, we got our RBCs here, our red blood cells. We got all of our white blood cells here and here. What did I not include as part of the form elements? It starts with P, plasma, but in the plasma, platelets. So those also come from here. So let me add one more thing. There's a cell called the megakaryocyte. TPO, thrombopoietin. I won't even write it out. I always go by TPO like EPO. That's a factor, stimulating factor that will stimulate the hemocytoblast to form the megakaryocyte. And those will give rise to the platelets. Or thrombocytes. I won't talk about those today. They basically can initiate the blood clotting. And anyways, that's all formed elements. The thrombocytes, check, monocytes, all these granulocytes, RBCs, that's the formed elements. All right, so that's everything. How they all, the concept is genesis of blood cells, how they're formed, right? Cool. Well, let's talk about functions of these. And you have nice pictures in your book. And in terms of a little memory jogger, never let monkeys eat bananas. The prevalence, right? The most of these, the most you have is the neutrophils, the lymphocytes, and on down. Okay. So in a drop of blood, which are hardest to find? Basophils. Yeah. Maybe I've seen it once on one of our slides 1 year. So I won't have you try to find those. But anyways, you should know the functions. This is physiology, so I gotta go to the functions real quick. So I'll try to summarize what's there. What should you know about these? First, can I recognize one in a microscope slide or given a picture? What's unique about these, not only their color, look at the nucleus. It's not round, is it? Polymorphonuclear. How do we say it there? Multilobular nucleus. That's the number one thing I look for. Multilobular nuke. Okay. The other thing in terms of function is these are phagocytes. Phagocytes are great. They're just like garbage collectors. They go out and they find anything in your lymphatic system, anything, they just kind of initiate an immune response. Okay. Like I say, their granules have antibiotic function. So they're good phagocytes. In a word, that's what they do, that's their function. So a high count may indicate some kind of infection. Eosinophils, they're red. Remember, eosin means red in this class. So what you got to do is look for the reddish color and look for the bilobe nuke. They're basically good at attacking parasites like large parasitic worms. Usually not a problem in westernized countries, but, well, that's what they do. They attack parasites. Now the lymphocytes, usually when I see them, they're all nucleus. You barely see the cytoplasm. Maybe you see a little rim of cytoplasm, that's it. It's just large round nuke. Maybe a little rim of cytoplasm. Now, the other thing is, you got two kinds, the B and the T. There's subpopulations of B and T, but basically the B cells, they're the ones that are the antibody generators. They're antibody factories. Secrete antibodies, ABs. The Ts, one of the subpopulations, they can directly attack virus-affected cells. More on them later. Getting to the monocytes, they become macrophages. Macrophages are another great parasitic function cell. I would say that's the most important thing. And how you identify them? They're rather large. Look at the cell type. Remember how big RBCs are? Maybe 8 microns. So these, when you see it right next to a red blood cell, not in this slide, but you kind of see they're about double the size. And they have a kidney-shaped nuke. That's the number one thing I look for. And then the basophils. Basophils have a nucleus, but you usually can't see it. It's obscured by the dark granules. They stain so dark and so blue, you can't see the nuke. And that's usually all I see are the granules. So the basophils, with their dark staining granules, you don't see the nuke. Their main function is they secrete histamines. Histamines are chemicals that draw fluids to an area of infection, causing for example, the redness and swelling when you get an infection. That's flushing out the pathogen. Secrete histamines. You know, like an allergic reaction, and you drain, and it's annoying. So you take antihistamines, like Benadryl, makes you drowsy, but they work. You dry up. Let's take a break, and when we come back, I want to talk about blood coagulation. Come back at 9:15.